Hello students and welcome to my channel Maths Hub. So today in this video I'll tell you about the half range series, right? So for a half range series we have two types of series. One is half range Fourier cosine series and the second one is half range Fourier sine series. So let us know in details what are these half range series. So to begin with, let us first study what is a half range Fourier cosine series. Now, if the function is neither periodic nor it is even nor odd, then to obtain a Fourier cosine series in the interval 0 to L, what do we define? We try to define a new function gx such that it is an even periodic extension of this function fx. So how do we even periodically expand it? We write g of x is equal to f of x in the interval 0 to L, and we define gx to be an even periodic extension. So it is the interval then will become from minus L to L, and it will become periodic with the period 2L. So then gx is known as the even periodic continuation of this function fx. So if it is an even periodic continuation in the interval minus L to L, then how do we define g of x? G of x is same as even Fourier series. So it is a naught by 2 plus summation n going from 1 to infinity a n cos n pi x by L. So in that case, a naught and a n are given by the same formula. So a naught is 2 by L 0 to L gx dx. So gx will be same as fx because gx is just the even periodic continuation of the function fx. And an is also defined in a similar lines, 2 by L 0 to L f of x cos n pi x by L dx, right? So in a half range Fourier cosine series, instead of giving the entire interval minus L to L, you will be only given the interval 0 to L, right? And we define a new function gx as an even periodic continuation. And from there, we try to get the Fourier series expansion, the half range Fourier series expansion for fx, right? So this is how we define it. G of x is fx in the interval 0 to L, and g of x is f of minus x in the interval minus L to 0, right? Likewise, when we define the half range Fourier sine series, here again the interval will be given as 0 to L. So we try to define a new function hx, which is an odd periodic continuation in the interval minus L to L. So if it is an odd periodic continuation, so the hx will define as an odd function and it will have the same Fourier series as we did for a odd function. So in case of odd function, we know that a naught and a n are 0. So hx will be simply summation bn sin n pi x by L. So bn will be given by 2 by L 0 to L h of x sin n pi x by L dx, and hx is same as fx. So how it is an odd periodic continuation? Hx will be defined as fx in the interval 0 to L, and it is minus of f of minus x in the interval minus L to 0, right? So now, based on this, let us do one exercise. So you are given that the function fx is 1 minus x by L defined over the interval 0 to L, and we need to find the half range Fourier cosine series and the half range Fourier sine series for the given function, right? So let us try to do it. So I'll do the first part, the A part, half range Fourier cosine series, and I'll leave an exercise for you to calculate the half range Fourier sine series, though the answer is provided already in this video, right? So you just need to do it on your own and check your answer. So for the half range Fourier cosine series, we need to calculate A naught first. So A naught is basically 2 by L. So in this case, your length of the interval is L only. 0 to L, f of x is 1 minus x by L dx, right? So this is 2 by L. Integration of 1 is x. Integration of x is x square by 2, and we put in the limit 0 to L. So this is 2 by L. We have the limit L here. So this is L minus L square by 2. 1 L will get cancelled. So I'll get L by 2. This is L by 2, L by 2, and 2 by L will become 1 from here. Right? Now let us calculate AN. So AN is 2 by L, 0 to L, 1 minus x by L cos n pi x by L dx. So let us integrate it, integration by parts. 1 minus x by L constant, integration of cos n pi x by L is sin n pi x by L divided by n pi by L. Then derivative of this is minus 1 by L, and then integration of this part is minus cos n pi x by L divided by n square pi square by L square, right? And the limits are from 0 to L. Let's see which terms become 0. So when you put the upper limit L, sin n pi is 0 and 0 will make it 0. So this whole term gets 0. Let's see what is the term that we get from here. So 2 by L was already outside, minus 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 is plus, then we have 1 by L, then we have a minus sign, and then we have L square upon n square pi square, right? And now let us put in the limits. Cos n pi is minus 1 raised to power n, cos of 0 is 1. So L gets cancelled. We get minus 2 by n square pi square. So let's categorize into n even and n odd case. When n is odd, this is minus 1, minus 2 is 4, 4 by n square pi square. And when n is even, this is 1, 1 minus 1 becomes 0, right? So what is your Fourier series expansion then? F of x is a naught by 2, so this is half plus summation n going from 1 to infinity. It's opening for odd case, so we can write it as 4 upon 2n minus 1 square pi square cos 2n minus 1 pi x by L. So this becomes my answer, right? So for half range Fourier cosine series or for half range Fourier sine series, we'll use the same formulas as used for even and odd functions. And then I'm leaving this exercise half range Fourier sine series. You can check your answers over here. So the values of Bn I've already calculated. So you just need to do the integration part and check it on your own. And this is how you'll get the Fourier sine series expansion, right? So I hope you have understood what is half range Fourier sine series. So if you like the video, do hit the like button, and those of you who haven't subscribed my channel yet, do subscribe my channel to get the latest updated video, and believe in yourself and you will be able to succeed. Thank you.